Chapter 1, How to Install Python, Navigation, and Your First Program. Hello everyone, welcome to Browning's Introduction to Programming. This is the 5th edition, and so we'll be going through 15 chapters. Each chapter, I'm going to go ahead and assume that you've at least looked through the chapter a little bit, and we'll hit the high points as if you were going through a lecture in class. Chapter 1. So Python is an open source language, a language where the actual code of the program is given away for free. There is open source where you do actually have to pay for it sometimes, but most of the open source is free software, and the big catch is if you change the code, you want to make sure that you give the original code in addition to the code that you changed away. So you can make derived copies if you'd like from that. It's an extensible language, which means that you can add features easily, as we will certainly do. People around the world are working all the time to help improve Python, and in fact there are two versions of the language. There's a Python 2x, or 2.1, 2.2, 2.3, etc. There's a 3x. They are slightly different languages, but conceptually they work about the same. We're focusing on Python 2 for this text. It's also a cross-platform language, so you'll find that it works with the same code with very minor changes depending on what you're doing for Windows, Macintosh, or Unix, Linux-based systems, or other platforms as well. Open Source Initiative has quite a few different licenses for distribution. However, they all adhere to the open source definition, which states open source software that can be freely used, changed, and shared, modified or unmodified by anyone. And basically, if you go to opensource.org, you can look that up. You'll also probably hear of GPL licenses and things of that nature, which are related to that. Now, so again, we're working with Python 2. That's very important that you'll note that. You want to look for when you're using libraries or just different software or open source software in general. They may have alpha or beta releases. You may also see stable or testing releases or experimental. Basically, an alpha release may have some bugs in it. Beta is a little more stable, but it's still an experimental release. A stable version may not have all the latest features, but they know that that version of the software doesn't have any bugs in it or has minimal bugs in it. So for probably most of your use, you may want to use a stable release, but if you want to be on the cutting edge or bleeding edge, as you'll hear used, certainly a experimental alpha or beta version, no problem using that. All right. I haven't use the alpha and beta releases a lot of the time, unless it's like a production job. If it's a production job, I would probably stick to stable releases. How to install Python? You want to install and follow the instructions on the Python site, and it is python.org, not python.com. The extension does make a difference. But long story short, you want to install the latest 2.x version to use the code in the book. Now, if you're using a Mac, the instructions will be slightly different, but they're certainly available on the site. I would download the installer and then run the install on your computer as opposed to running the installer online. Let's see, options that you want to look at for that. Once you get that installed properly, and of course you'll need administrative rights to do that, you're going to have a general programming environment that comes with the standard Python package. It's called IDLE, and that is your IDE, your Integrated Development Environment. There are a lot of different IDEs out, but IDLE is the one that comes by default with Python. That's what we'll use in the book. There are other IDEs though that are out that are also free and very powerful. You might look at NetBeans. If you're a Visual Studio Microsoft user, you could use IronPython. Komodo is not totally free. If you're a student, I believe you can get it for free, but they seem to change that from year to year. Eclipse is a good one. And Eric is one that you might try, but certainly others. I think my first attempt, if I was going to try something other than the built-in default IDLE, I would use NetBeans, just because it supports other languages. It's a common interface, very easy to use, and very powerful. And it's updated a lot as well, so they're always doing interesting new things with it. So a little bit of computer history and how the computer works. It's interesting to note that early computer programming languages initially did not have an IDE. It memorized the commands to perform different steps of the programming process. And in fact, this programming on a computer itself, really, the machine only understands two states, on and off. Off for one, or on, 0, on for 1 or any positive integer value. So again, 0 for off, 1 for on, and it's the software represents electronic switches and circuitry in the actual electronics world. So that's kind of the cool thing. We're doing it in software, but actually there's some electronics going on behind the scenes. Now there are quantum computers out, which they have 3 bits. They have an off, an on, and they have this weird thing called a qubit that can go either way. We won't be doing that. A little tough to represent that on a binary system, binary being 2, 1 and 0. But that being said, there are quantum computers out. For a low cost of $15 million, you could have one as of 2019. Alright, so newer IDEs, typically they have color context sensitive highlighting. So different parts of the program code would be in different colors. For example, keywords might be in one color. Keywords are words that do things like print or display or beep. Comments might be a different color. Comments are things that are just for you. They don't do anything per se. Let's see here. Other things that you might want to look at. We want to know about, at the bottom page, the first chapter, BASIC, Beginner's All-Purpose Symbolic Instruction Code. Actually, there are 3 big languages that first came out, and there was BASIC, which was used for teaching, and certainly it's evolved to other language, Visual Basic, and other things that are used in commercial environments. They're certainly not used for teaching anymore. I mean, you teach with them, but they're robust commercial languages. Fortran, Formula Translator, which was a language for a scientific community, and then you had COBOL, which is a business language, which was developed by none other than the famous person who coined the term debugging, Grace Hopper. We'll talk about her later on, but back in the day, as the joke goes, older programming, you didn't have a mouse-driven GUI. It was totally console-based. And matter of fact, a lot of the older computers, you had to physically rewire them to program them. Not the quickest route to come up with interchangeable software. Guido van Rossum is the man responsible for creating the Python language. He is still alive as of 2019 and a fairly young man. So you want to be familiar with his name. Basically, anyone who makes major changes to the Python language typically wants to have a nod from Guido to make sure that he's okay with it. They call him the grand dictator of the Python language, but it's just kind of a tongue-in-cheek joke. Let's see here. Modes of operation. You want to be familiar with that. There's interactive mode and script mode. Other languages support this as well, such as R. You'll see the interactive and script mode. But interactive mode, you run a program one line at a time. So every time you enter a line, it runs that line of code. Handy, but it's when you get done running the program, there's nothing saved. It's good for little short programs for testing things. Script mode is where you actually write a program and save it. You can come back to it and edit it. You can give it to somebody. You work on it in a team. Script mode is what we'll do a lot of the time. When you're going through the book, the examples will specifically say, script mode or interactive mode. So just note, what it says. All right, how to use idle. This is assuming that you have that installed properly. If you follow the hands-on with that, it will walk you through how to use idle. Try that out. Stop this tape or this recording, and then try that out, and you should actually see Hello World displayed, and that'll be your first program. Alright, well, you should have got that to work properly. Script mode is the next hands-on, and again, script mode, you're going to save the file. Now, it's very important that when you save the file, make sure you type the .py extension when using idle. If you don't do that, It'll still be a text file, but it won't associate it with Python, which is not what you want. You want it associated with Python, so make sure you type that .py extension. Try that out, and let's see how that works. Alright, so you got that to work properly. If you look at the color context highlighting, you can change these colors if you want by default. Keyword orange, strings are light green, comments are red, noted with the pound sign, and again the compiler ignores those, so you don't need to worry about that. Your output, of course, is blue. Error, we're never going to have errors. No, of course we're not. Well, in this particular case, the errors are red, evil red. Alright, let's try the next simple input-output program. You're generally going to want to get something from the user, ask them a question, ask them for a number, whatever. So in the next example, simple input-output program, type it exactly as you see it. Do not enter a number. I want you to type the words enter a number, just as you see it, and then run this program. What it's going to do, it's going to ask you for a number, it's going to multiply it by 2, and then it's going to print the result of whatever number you entered multiplied by 2. Stop the recording, try that out, and then click resume when you're ready to go to the next part. So, kind of an interesting example there. Multiplies it by 2. Obviously, it could be anything. And you could change that around, too, if you wanted to. Instead of x times 2, you could ask the user to enter a number to multiply by, and you could say x times maybe z if you wanted to. And if you entered a 2, it would multiply whatever number you entered by 2. Short list of mathematical operations, common across languages pretty much, but not exactly. You have addition, subtraction, multiplication we've just seen. Division is a slash. Some languages do division and then they do whole number division where they drop the remainder. Python just does regular division, but it handles it in a different way. If you give it two whole numbers, it does whole number division. If you give it a fractional value, 1.1, and a whole number, it promotes the second number to a fractional value, and then it does fractional division. So that's kind of interesting. If you do some division work with both whole numbers, you may end up not getting the remainder you expected. Promote one to a more precise value, 1.0. If you just did that, it would still make it a floating point. It would do floating point division. We'll get back on that a little later. But just FYI, last one is modulus. Modulus is only the remainder of integer division. So it'll do integer division on two numbers. Whatever the remainder only is what modulus gives you. It's not a percent sign. So try out the next example to see how that works. Use of the operators, and you'll see exactly how those math operators work. Resume the recording when you're done. Okay, that's a whole bunch of numbers. Wow, alright, but it did work. Alright, well, now what you can do to make your program look a little cleaner is if you'll put a couple of spaces, 2 spaces after the colon on your input prompt, what you'll notice is it reads a little better. The numbers aren't jammed up all next to each other. Certainly a little nicer there. Next item up for bid is you can put inline comments after some of your code. Sometimes this is handy. I'll do it just for me to let me know on a big, huge program that's maybe thousands or 5,000, 10,000 lines. You may want to leave yourself a note about what you were thinking at a certain place in the code. Or if you're working with a team, you leave some notes for the next team member. So in this case, we have result equals x plus y pound sign addition. The pound sign addition is not going to display. It's just there in code for you, kind of to make your code a little bit more self-documenting, which is a term you'll hear used in the programming world. So you've noted the changes there. You've seen what's going on. There's some terms to know there at the end, which are kind of important. What we've discussed: rapid application development, RAD. Python is a RAD language. Not RAD as in radical dude, but as in RAD as in rapid application development. The definition of basic, beginner's all-purpose symbolic instruction code. You've seen some of the other definitions as well. Try your hand at the activities at the end of the chapter, and that will certainly help reinforce your knowledge of Python programming. And then we will continue with Chapter 2. Have a nice day.